All right, let's do day 3 notes on calorimetry. Calorimetry is a way to measure the amount of heat absorbed or released during a chemical reaction. In a system, the amount of heat released must equal the amount of heat absorbed by the surroundings. And this is because of our first law of thermodynamics, which is the law of conservation of energy. Law of conservation of energy. And this is measured with a calorimeter. Calorimeter. All right, let's try a practice problem. A 46.2 gram sample of copper, so that's our mass for copper, Cu, is heated to 95.4 degrees Celsius, our temperature initial of copper, and placed in a calorimeter containing 75 grams of water, mass for water, H2O, of water at 19.6 degrees Celsius. That's our TI, temperature initial for water. The final temperature of the metal and water is 21.8 degrees Celsius. That is going to be our temperature final for both water and copper. What is the specific heat of copper? The specific heat of copper is going to be C for Cu, copper, and we're looking to find this. We're given that the specific heat constant, the C value for water, is going to be 4.18. So we know that C of H2O equals 4.18. When we solve these kind of problems, we always have to ask ourselves, what information do we have the most of? And when we look at this equation, or problem, we know that we can form a Q equals mc delta T equation with the information of water. And I'll tell you why we do that in a second. Let's find the delta T of water first. Delta T of water is going to be temperature final minus temperature initial. And the temperature final of water is going to be 21.8 degrees Celsius right here. And the initial value is going to be 19.6 degrees Celsius. All right, so let's set our equation up. The temperature final is 21.8. The temperature initial is 19.6. When we do this, when we subtract these, we're going to get 2.2 degrees Celsius for our delta T for water. All right, now we can set our Q equals mc delta T equation up. Q equals m times C times delta T. And mass of water is going to be 75 grams right here, 75 grams, times the C value of water, which is given right here, 4.18, 4.18, times delta T, which we calculated here, 2.2. When we multiply all three of these numbers together, we're going to get a heat value for water of 689.7 joules, which is our heat. All right, now what we cover on top for the notes is that in a system, the amount of heat released must equal the amount of heat absorbed, right? So if water absorbed 689.7 joules of heat, then the copper must have released 689.7 joules because you cannot create energy or destroy it. The law of conservation of energy, states that if you have 689.7 joules of heat entering, because it's positive, then you're going to have negative 689.7 joules of heat exiting. You cannot create or destroy energy, so this must always be zero. If you enter 689.7 joules, you must exit with negative 689.7 joules. So then we know that the Q value of copper must be equal to negative 689.7 joules. That is our Q value, heat value for copper. Now we have enough information to solve for the C of copper, the specific heat of copper. Let's set this up. The equation is the same, Q equals mc delta T. Let's set it up using our newly found Q. Q is negative 689.7, and that's going to equal the mass of copper, 46.2 sample, 46.2 grams, 46.2, times the C value that we want to find, times our delta temperature. Let's find the delta temperature of our copper real quick. Delta T is going to be the same, temperature final minus temperature initial. The temperature final of copper is going to be 21.8 degrees Celsius, and our initial temperature for copper is going to be 95.4 degrees Celsius. We're going to do final 21.8 minus initial 95.4, which gives us in the end a delta T value of negative 73.6 degrees Celsius. And we're going to plug that straight into here for delta T, negative 73.6 degrees Celsius. The way we're going to solve for this is going to be like this. Let's draw that arrow a little better. We're going to do negative 689.7 divided by 46.2 times negative 73.6, which is going to give us our C value. All you got to do is multiply this number with this number and divide it using this number. You want to divide negative 689.7 by the answer you get by multiplying 46.2 and negative 73.6. All right. When you solve this, you're going to get a C value for copper of 0.203. The unit for C is always joules per gram times degrees Celsius. That is your final answer. 0.203 joules per gram times degrees Celsius. And that's it.